pairs, and like I said, we learned those in lesson 14. Now that we know those angle pairs when we have a transversal, we're going to introduce some properties. Things happen to those angles. They follow special rules when you have parallel lines. And this is the first one. It's called corresponding angle postulate. It says if two parallel lines are cut by a transversal, which is the picture we just had there, also the picture here. Notice we have parallel lines and a line going through them. The pairs of corresponding angles are congruent, and we talked about what corresponding means. So for this angle 1, notice for this intersection here, angle 1's in the top left-hand corner of it, it would correspond to angle 3, the top left-hand corner of this intersection. Does that make sense as far as how we decide that they're corresponding angles? Okay, and it says that when they're corresponding, they are congruent. So we know angle 1 and angle 3 are exactly the same size. If this were a 110-degree angle, angle 3 would also be a 110-degree angle. The same for the 3 other pairs of corresponding angles in the picture. So 2, it's in the upper right-hand corner, would be congruent to 4 in the upper right-hand corner. And down here, 5 would be congruent to 7, and 6 would be congruent to 8, because they are corresponding angles, and that's called the corresponding angle postulate. So in this picture down here, what would the measure of angle ABC be? Now angle ABC goes from A to B, B's in the center, it's this angle right here. What would its measure be, given that picture? And the postulate that we just talked about, what would be the measure of that angle? Okay, so if we look at our picture, we have a set of parallel lines. We have a transversal cutting through them. Okay, notice when we had that transversal come through, it created 1, 2, 3, 4 angles here, and 1, 2, 3, 4 angles here. The postulate up above tells us if they're corresponding angles, meaning they're in the same place in their intersection, then they're congruent. So using that postulate, notice this 80-degree angle is the upper corner of its intersection. The X is in the same place. They are corresponding angles, so if they are corresponding, they should be congruent, and this angle would be 80 degrees. Okay. Oddly enough, we can actually fill out this entire thing. We can tell exactly the measure of every angle in this picture. We've answered our question, but let's go on and see that this is a very powerful postulate because it lets us fill in the angle measure of everything in this picture by just knowing one. Okay, the reason for that is, notice here we have vertical angles. This angle and this angle here are across the intersection from each other, and a long time ago we said those are called vertical angles, and vertical angles are always congruent. The same thing here. This angle and this angle here are across the intersection from each other. They are congruent. This angle A that we have here, notice these two make a straight line. Let me highlight them. I'll highlight them. These two angles here make a straight line together, and a straight line is 180 degrees. So if we needed to, we could fill in and say what angle A is. What do you add to 80 to get 180? You add 100. Okay, this across from that we have the vertical angle 100 degrees. These A and B are corresponding angles. That would make this 100 degrees and this 100 degrees. So we were able to fill in. We only have two different angle measures. Half of the angles are 80, the other half are 100. But using just this one postulate and a little bit of background information that we knew about linear pairs and vertical angles, we were able to fill in that entire chart. But the answer to their question, what's the measure of angle ABC, was really fast. Corresponding angles are congruent. So if this angle was 80, its corresponding angle was also 80. So answer this question then. Find the measure of angle QRS. Okay, I do this carefully. This would be angle QRS right here. But we can still work this out. Let's first find the measure of x. How many degrees is x going to be? Again, notice we have a set of parallel lines. And with those parallel lines, we have a transversal coming through it. Okay? This 110 degree angle is corresponding to this x degree angle. So that makes this angle 110 degrees also. Okay, so if they asked for x, I would know x is 110 because those are corresponding angles. They didn't ask for x. I need to go one step further. I need the angle right next to it. Notice that those two angles are a linear pair. They make a straight line together. Okay, so a straight line is 180 degrees. What would that other angle have to be? Angle QRS plus my 110 degree angle together should be 180. I'm going to solve by subtracting 110 to find out how many degrees are left over for angle QRS. And I find that it has to be 70 degrees. Okay. Again, if I wanted to, I could fill out the entire rest of the picture and all of the angles. This would be 110, this would be 70. Corresponding angles tell me this is 70, and this is 110.